You have chosen answer A, that the first section must have the different diameter. Now, how do we determine this? Did you measure the pressure drop along the pipe? Now, the pressure drop for steady laminar flow should be constant along the pipe for a given material in diameter. So we would expect a constant drop in pressure per length of pipe. So we take the difference in pressure readings, the drop, and divide by the distance between the reading. So if we start with our first section, we have 5 feet remaining of section A plus the 9 feet to the next gauge, 14 feet and 0.22 psi. Now this gives us pressure per length, roughly 0.016 psi per foot. Now we could repeat this for these two gauges. We get 0.48 psi per 11 feet of section B remaining, plus the 13 feet is 24 feet. This gives us 0.02 psi per foot. So we can already see that the pressure drop is different. So we need to validate with one more pressure reading. We do that from the gauge in section C to section D. 7 feet remaining is C, plus the 13 feet is 20. We have 0.4 psi per 20 feet. This gives us what we saw before, the 0.2 psi per foot. So we see that the reading between section B and C and D are the same. That's what we would expect for the constant pressure drop. Since the pressure drop is different between the first and the second, but not the second and third, so we're talking about the difference between these two rather than these two, means that section A must be the culprit. Thus, the answer A is correct. Now, the real question is the pipe section larger or smaller? Now, for steady laminar flow, we could relate the Reynolds number to the frictional factor as just 64 over the Reynolds number. Reynolds number is written as the density times the velocity of the fluid times the diameter of the pipe over the viscosity of the fluid. Thus, an increase in pipe diameter is going to give us an increased Reynolds number, and therefore the frictional factor is going to decrease. This means that the losses associated with the friction is going to decrease, and therefore lower frictional losses means less change in the pressure along the length of the pipe. So the pressure drop per length will decrease. Since we have a smaller value between the two gauges in A and B, we would expect that the diameter in section A is larger.